Alright, we are from group 3. We present to you line integral, which is the topic that we choose. So, for the group members, Wafiq will responsible for question 2 and filming presentation video and distribute roles for each member. For Arfaikal, responsible for question 1 and filming introduction and question video. For Muhammad Imran, responsible for question 1 and filming the presentation video and discussion on introduction and conclusion. For Adam Minullah, responsible for question 2 and filming the presentation video and discussion on introduction and conclusion. Alright, so for introduction, a line integral is an integral where the function to be integrated is evaluated along the curve. There is numerous terms also used such as partial integral, curve integral, curvilinear integral, and contour integral. Many simple formulas such as W equal to F multiplied by R in physics, where W is work, F is force, and R is the displacement vector. In this case, we use W equal to integral of Fr multiplied by dr, which computes the work done an object moving through an electric or gravitational field of F and R. So below is the how we derive from the equation above. Clear purpose and outcomes is to understand the definition and concept of line integral, to understand the application of line integral, to find solution of any question given related to line integral, to develop teamwork among team members, to develop skills and knowledge in correcting mathematical software, and to develop soft skill by presentation in video form.
And the question, evaluate x minus y dx minus xy power of 2 dy for each of the following curves. A. C is the portion of the circle of radius 6 in the first, second, and third quadrant with clockwise rotation. And B. C is the line segment from 0, -6 to 6, 0. Let's go to the question A. And let's start off with a quick sketch of the curve for this part of the problem. And this is the sketch. And then here is the parameterization for this curve. And we will get the point x is 6 cos t and the point y is -6 sin t. Here is the line integral for this curve. In this curve, we will substitute x with the 6 cos t and the y with -6 sin t. And then we will calculate the equations. For the final answer, we will get 342 minus 27 pi is equal to 257.1000. Don't forget to correctly deal with the differentials when converting the line integral into a standard integral. And let's go to the question B. Let's start off with a quick sketch of the curve for this part of the problem. And here is the sketch. So, what we have in this part is a different curves that goes from 0, -6 to 6, 0. Despite the fact that this curve has the same starting and ending points as the curve in the first part, there is no reason to expect the line integral to have the same value. Therefore, we will need to go through the work and see what we get from the line integral. We will need to parameterize the curve. So let's take care of that. So, we will get the point x is 60 and the point y is -6 plus 60. Note that we could have just found the equation of this curve, but it seemed just as easy to just use the vector form of the line segment between 2 points. Now, all we need to do is compute the line integral, and as usual, we will substitute x and the y in this equation, with x is with 60 and y with -6 plus 60. So we complete the calculation, and then the final answer, we will get the answer is 144. So, as note at the start of this part, the value of the line integral was not the same as the value of the line integral in the first part, despite the same starting and ending points for the curve. Note that it is possible for two line integrals with the same starting and ending points to have the same value, but we can't expect that to happen, and so we need to go through and do the work.
Hi, good morning. My name is Muafiq. I will present a question from line integral. So the question here, given a function and ask for the line segment from point 17 to negative 2, 4. So the first thing, we need to sketch the graph to see it clearly. This is the point 17 and this is the point negative 2, 4. So based on the graph, we have write a vector for curve C1. So let's call it curve C1, and this is the parameterization of C1, as we get 1 minus 3t for x and 7 minus 3t for y. Alright, for the next step, we will use integration based on the function given. So here we have separate the integration into two for x squared dy and y plus 1 dx. After that, we will substitute the value of x and y. So here we change the delta y and delta x into delta t because we use the parameter t here, and for the boundaries we use 1 to 0, and after that we simplify the integration and combine it into 1. So after that we just integrate into using the boundaries 1 and 0. So we will get the answer, the last answer is 93/4.
My name is Adam Aminullah bin Bakri. I'm going to answer the question B. The question is, evaluate the integral of x power of 3 dy minus in bracket y plus 1 close bracket dx for each of the following curve. C is the line segment from negative 2, 4 to 1, 7. Using the coordination that we get, we can plot the graph. Now, as we did in previous part, let's rename this curve as C2 instead of C. Next, note that this curve is just curve from the first step with opposite direction. In other words, what we have here is that C2 equal to negative C1. Here is a quick sketch of C2 for the sake of completeness. Now at this point, here are two different methods we could use to evaluate the integral. The first method is use the fact from the notes that if we switch the direction of a curve, then the value of this type line integral will just change sign. Using the fact, along with the relationship between the curve from this part and the curve from the first part, C2 equal to negative C1. Note that the first equal sign above was just acknowledging the relationship between the two curves. The second equal sign is where we use the fact from notes. This is the easy method for doing this problem. Alternatively, we could parameterize up the curve and compute the line integral directly. We will do that for the rest of this problem, just to show how we go about doing that. Here is the parameterization for this curve. We must use negative 2, 4 as x naught and y naught, and find value of a and b, then insert it in the equation to get the value. First, put the x and minus with x naught. 1 minus negative 2 multiplied by t, and we get 3t, and this 3t is for x. Combined with x naught, we get negative 2 plus 3t. This answer is for x cubed. Same with another equation with the same step. Now we all need to do is compute the line integral. Integration of x cubed dy minus y plus 1 dx equal to integration of x cubed dy minus y integration of y plus 1 dx, and put the value that you get, and integration of upper bound 1 and lower bound 0. 3 multiply in the bracket negative 2 plus 3t power by 3 dt minus upper bound integration upper bound 1 lower bound 0 in bracket 4 plus 3t plus 1 and multiply 3 dt, and we get 1 over 4 in bracket negative 2 plus 3t by power of 4 negative 15t minus 9 over 2t squared, and insert the upper bound 1, and we get negative 93 over 4, because if we insert in value of 0, we also got 0.
Right, here our goal and explanation. Group members can understand the definition and concept of line integral. Group members can understand the application of line integral. Group members can find the solution for any question given related to line integral. Group members can develop teamwork among them successfully. Group members can increase their skills and knowledge in interactive mathematical software. Group members have developed their soft skills by presentation in video form. Alright, and then this is conclusion. In line integral, the curve doesn't influence work done as long as the displacement vector is still same. There are few applications for line integral, especially in physics. First, mass of wire. Second, center of mass and moments of inertia of wire. Third, work done by magnetic force and on an object moving in vector field. Fourth, magnetic field around a conductor, which is called Ampere's law. And fifth, voltage related in loop, which is called Faraday's law of magnetic induction. So this is the reference we use in our assignment.